Alright guys, in this video we're going to look slightly at unit testing, but you're going to look at unit testing more specifically from your assignment perspective, or your assignment 1 perspective. And a couple of questions, at least few questions of PSR is on this idea of how I would go about testing something where a function is printing something on the console, or how I would go about testing something where I'm going to take in some input from the user. Alright, so these are some of the common questions, and in fact these are really good questions, and one way to get around this by using unit testing is actually to do some refactoring. Is to do some refactoring on your code. So what I'm going to do now is I'm going to take that idea, and what I'm going to do is let's just make something really simple. Let's just make something called a calculator, and this calculator is going to be a really dumb calculator. It doesn't do much nice things, but let's just make it an attempt to create something called a calculator. All right, so I've got a class that I'm just creating. I'm creating a blueprint here. I'm creating a blueprint for my class calculator, and I'm going to go ahead and create a constructor. Alright, so that's my constructor, and the constructor doesn't do anything much, so I'm just going to have it as a body of my constructor. I'm now going to have a method. I'm going to have a method here, which is, let's say, add to number. Okay, so what this method is going to do is, it's an instance method. It's an instance method because it takes in as a local parameter a self. It takes a reference self. Okay, and there's something interesting here. Let's have this method ask the user to enter two numbers. So I'm going to have x equals to input, enter a number, and then I'm going to copy paste that line again so that I can get the second number from the user as well. And then I'm just going to do something really silly where I'm going to say, let's say print the integer version of that x, whatever x is, plus the integer version of the y. And I feel really kind of happy in some ways that I've got the specs of this method completed, where I'm taking two numbers, x and y, and I'm adding it together, and I'm just printing it back on the console. So a couple of things you should strike immediately from this, from what I've done right now. First thing, what I've done here is, if you notice, I'm taking two inputs from the user. All right, so this is coming from the user. Okay, it's from the user. Okay, and more specifically, if you're curious, it's coming from a standard input. Okay, so you might learn about standard input a little bit later in the second year maybe, but right now these are things coming from the console. So this is basically from the console, from a standard input, and then I'm taking the integer, because remember x and y basically happens to be string. I'm taking the integer version of that, and then I'm again printing the output on the console. I'm printing the output on the console, or more specifically, I'm printing it out on standard output. Standard output. Okay, it just means right now I'm dumping the output on the console. Okay, so my question now is how would I even test this method? I want to test this method that my implementation for adding two numbers is correct. So if the user passes in, let's say 5 and 6 as my number 1 and my number 2, I'm able to add the two together and get back 11. So this is the function. This is the core of my algorithm here. This is the core of my method. The method is supposed to take these two numbers, add them together, and you get back 11. Question is, how would I even test this? How would I even test this? Okay, so to test this, you need to write write some unit testing. But before even doing that, let's just run this. Let's just run this just to make sure things are okay. So so let's do this. Let's create a calculator. Let's create a calculator. Let's say x equals to calculator, and let's do two numbers, and let's pass in 5, 6, and let's just run this. Run this code. Alright, so these are coming from the input. There you go, that's better. And let's just enter a number. Let's put that 5, enter a number 6, and I should get back 11. Alright, so far so good. This method seems to be doing something correct, but what I would like to do is write some unit test. Okay, so in order to write my unit test, I'm going to create a file called test.py, and let's just get rid of everything just for time being. Let's just get rid of maybe the, let's do this. Let's get rid of the line just for time being. Okay. So what do you have here? First thing, I'm making sure I'm importing my unit test. Okay, so make sure you get all your appropriate libraries, all the appropriate modules imported. So that's my module for my unit test. This piece over here is where my code happens to be. The user input code is right there. This is where all my calculator happens to be. This is a module where my calculator class is. So I'm making sure that in my test.py, okay, now again, that's a bad naming convention. It's a calling test.py, maybe I should say test user input code or test calculator or something, but that's okay. Let's just continue with this example right now. So I'm saying import the appropriate module. Okay, that's where the module is. What does this line tell you? The first line over here. The first line tells you there's some kind of inheritance. There's some kind of inheritance built into this. So I put my subclass, which is the test calculator class, that I'm just defining. Okay, so that's my child class. This is my child class, the test calculator, and this piece over here is my parent class. And what I'm saying here is that the test calculator is a class that happens to inherit from the test case class. Test case class is a class that happens to be inside the module unit test. That's what imported unit test right there. And inside that module, I have a class called test case that I'm going to inherit from. Okay, so I'm writing a new class called child that inherits from it. Okay, so far so good. And within there, I'm going to have a method that is responsible. So remember, all your methods should start from test underscore. Okay, all your methods should start from test underscore. That's important. So what I'm saying here is I have a method, a unit test to test the add two numbers. Okay, so now inside the body of this, I'm going to write some code that would actually test my add two numbers that happens to be defined inside the calculator class, which happens to be inside the unit input code module. Okay, so given all of this, let's write some code now. Okay, so let's get some space here so we can start writing code. But think for a second. My first question is, how am I going to put my code together that's going to actually uh, um, uh, test this method here? So let's go back to our method here. Method is add two numbers, but the numbers basically are these numbers from the user, and then I'm going to print something back on to the user. So I'm bringing back to the console. So in essence, this method doesn't take in anything as a parameter besides the self. Besides the self, it doesn't take in anything as a parameter. And likewise, it doesn't give back anything as a return value. It doesn't give back anything as a return value. And because it doesn't give back anything as a return value, it's really difficult to perform some assertion equal. I don't know what this method returns back to me, and I cannot do any assertion equal. So again, what I'm going to do now is I'm going to refactor this code. I'm going to keep the same functionality, but I'm going to refactor this out. So first thing what I'm going to do is I'm going to say, okay, I'm taking these inputs from the user X and Y, but why don't I define a new method? Why don't I define a method? Let's call it, let's do this. First thing, this is not really add two numbers. It's basically just make this method as get two numbers. So let's make this get two numbers from user. All right, and then I'm going to have a method called add two numbers that takes in an X and a Y, and it returns back return X plus Y. All right, and what I'm going to do at this point, I'm going to call that method add two numbers, which takes in the X and the Y from the user. Okay, and then I'm going to say at this point, I'm just going to say print whatever that output happens to be. Okay, so see what I've done here. What I've done right now is I've kept the same functionality. The method that was originally defined, pretty much the same thing. It's still taking the inputs from the user. I'm still taking the inputs from the user. Okay, these are still coming from standard input. This is still from standard input, and this is still printing on the console. It's still printing on the console. It's still standard out. But the core algorithm that I was interested in testing, I don't care. I don't care about testing the input method because the input method over here is written by the folks at Python. Okay, they must have tested this thoroughly, right? It's their method. They must have tested it before making it available to us. And likewise, the print method is a method from the folks at Python. They would have tested that thoroughly. I don't have tested method. What I'm really interested in is testing is my core algorithm, whether I'm able to take X and Y and add them together and get back the correct result of the addition of X and Y. So I have refactored that code out into a simple method right there. And look at this method here. It takes in something as an input. It takes in something as an input and it returns back something out as an output. Okay, so now I have some ability to test this method. I'm not going to test this method anymore because what does this method do? It's just calling input. It's just calling input. I don't care about testing the input method. I don't care about testing the input method. I don't care about testing the print method either. I care about this piece. But this piece over here is right there. And I'm going to write a unit test to, to, to test that method out. So I've kind of decoupled the core functionality out from that from the big method into a smaller method. And this method now has been decoupled, meaning it can be used in a console-based application. It can be written this x plus y to this get two numbers from the user, which happens to print another console. It could be running it to some other function where I would be printing it to a file, or I could be sending out an automatic email with the result of X and Y. So one of the nice things what I've done with refactoring. So this idea of taking the code and tearing it apart and decoupling it into a smaller method is what refactoring is all about. And look at this refactoring a lot more in detail in CSV 207. Alright, and now this has also got to this idea of decoupling. I have I have decoupled my code. I've made it less dependent. All it does now is takes an X and Y and gets the output. Okay, so with this, I can now go back to my test.py, and inside test.py, I'm going to say, let's just test this out. So I'm going to say self.assert assert assert equal, and I'm going to pass in there, let's say, the expected value. The expected value of 3 plus 2 is 5. Let's say if I get back 5 out, and that should be from user. Let's get the calculator. Let's create a calculator and let's call add two numbers, and let's pass in 3 comma 2. 3 comma 2 are basically just inputs coming from the user, right? Those are just inputs from the user. So now I can pass in 3 comma 2, and we can just see whether this actually runs correctly. So now let's just run the first test case. Let's just run this. So if I take my test.py and if I run this, so now that I've got my code a little bit cleaned up here, okay, I'm going to take my user input code.py, and I'm going to come inside test.py, and I'm just going to run my test.py, and let's see whether this actually runs correctly. So now I'm getting some message from my test runner telling me that my test.py has that started at 8:10 p.m. It did some running and it actually executed everything fine. I'm basically getting my test result. So this is because I'm running this from my PyCharm. It tells me that everything is okay. All my tests has passed here. Again, just to verify this, if I pass in 7 there, meaning that the addition of 3 comma 2 is this is the actual value. If the actual value and the expected value differ, meaning there's a failure in my test case. So if I were to run this again, I should get back a failure. So I'm telling the first thing that tells me over here that there's an assertion error where my test case has failed because I've got 7 not equal to 5, and this is the point where my test case has actually failed. Okay, so what I've done here is I've shown you a way of how to refactor some code, how to refactor in such a way that you can proceed with unit testing. But then the other question would be, how many test cases should I have? How many test cases should I have there? So now use your imagination, right? I mean, there's no. I mean, you need to think about some of the boundary cases. Like, for example, I'm testing over here for 3 comma 2. But what if I pass in one of these parameters as a 0, right? What if I make one of the parameters as a negative number? What if I have two negative numbers here? And these are boundary cases just to ensure that your method is still doing the correct thing when you have a different variety of inputs that have been passed into this method here. So just having one test case doesn't mean that I have, well, it doesn't mean that my code is completely fine. Likewise, even if I have 100 test cases, it doesn't mean my code is completely fine. But just for this first assignment, try to use a little bit of imagination to see that you can come up with some unique test cases to ensure that your method actually works correct.